Hello everyone. We would like to thank you all for coming, dear mentors, company representatives, and ambitious students. We would like to welcome you to our presentation, SenseWise, to give all your senses a break. Allow me firstly to introduce my team. And myself, of course. I'm Thea, this is Dominic, and we have Pavel, Shimon, Bob, and Marek. We worked alongside, for this Collider, we worked side by side on the Digital Ear Challenge for Asahi. Prasroy, you probably already know our challenge owner from the occasional beer, and from the occasional beer after school or after work. But let me give you an insight of what problems or tech difficulties you could have as a big brewery such as Asahi. You probably note that you are a big brewery, so you have big machines, and with that come big noises, but of course big problems and responsibilities. So you would like to ideally be in control of all of that because you're at a big risk of even bigger losses. So you want something that would listen closely to your machines, detect if any problems are there, and intervene in timely. But you're not the only one with this problem. Many other factories or laboratories face the same problem, and it's all over the same again. There's a defect, you're relying on human error, and then being at risk of fatal losses. This is where SenseWise comes with a simple solution. So we present to you a sensor network that is also connected to an AI-powered database or a software, and then again going to a really user-friendly interface for your workers to be happy with. That's the main part. We went to Velké Popovice, and we took a look around the brewery. We've confirmed that the main sensor that they really lack and they need the most is actually the microphone. They need to listen to their machines. They already have some other sensors. So this is where the prototype SenseWise Mark II comes from. Features 2 directional microphones that send raw audio signals to the master unit that computes the data and sends alert to the operational center if it's needed. So this is us at the factory, and this is our prototype. My colleague here, right here, will be passing it by, so you can have a closer look. This is just the sensor. So this is just our sensor, the 2 microphones that I talked about, but more about the AI from my colleague Dominic here.
Thank you. So I would like to give you some insight on the technical solution we have implemented. We've been given this challenge, which shouts machine learning, but we haven't been given any labeled data that we could train our machine learning models on. So we decided to split our solution into 2 parts. The first one is an unsupervised learning solution, which analyzes the sound. And the second part is a continuous learning phase. For the first one, we look at the sound, we extract as many features we can, and we're looking for weird sequences, some changes in the sound, either in the amplitudes or in the spectrum. We use for that our unique solution using Gaussian mixture models, modeling the spectrum of the sound and expectation maximization algorithm. For the second part, we employ deep reinforcement learning, which really enables us to tailor our solution for the customer. We can really get used to the sounds of their machinery, and we can improve over time. So for the demo, here you can see our application, and in the right down corner you can see what's happening with the sensor. We the graph you can see is the spectrum, the frequencies over time from the sound. You can use this to extract what the sound is composed of. Or you can use this to analyze the sound, to find these anomalies. Or machinery.
But the last step of the software workflow is allowing the user then to replay the noises and label it. So you just saw a demonstration of how our solution comes together, all comes together in real life. But this is our solution for Prosdroid, extracted from an extended diagram of our startup vision. As you can see, with our modular solutions, we are confident to say that we could provide various sized companies a turnkey combination of components tailored just for them, from static sensors, detectors, or smart plugs to walking robots or flying drones, all coming together through an AI-powered software and back to an easy, user-friendly interface, such as a mobile application that the worker could carry around, or to the command center. You may now be wondering how much could all of this cost? So let's relate our billing to Prosdroid and to this prototype that has just cost us around 85 euros. But as you know, with series production, we can drastically drop this price. We're looking now at around 24 euros per sensor, maybe even less. If you're looking for an A to Z solution without integrating to your existing infrastructure, then you should count the cost. So along with the master unit, you're looking at around 2,500 euros. But then also, as we mentioned before, we have additional services such as maintenance services or cross-reference data sets and integration into an existing infrastructure, is all coming with an additional billing fee. Now, we're confident about our prices. You're looking now at the cheapest solution that you could possibly have, but we would also be saving. Your investments will be paying off, since a qualified estimate of the anomalies detected by experts is around 60%, and you can add up 15% more with our sensitive sensors. By that, you're lowering the risk of losses that may occur and saving hundreds of hectoliters of beer per year, just in Velké Popovice. So think about how much beer could we save all around the world. But let's not stop just at beer. Let's go further. Let's see where we could apply our technologies even in other fields. So as I mentioned, factories and laboratories and technology, that's for sure. But then healthcare units, facilitating work and saving time for people, and researchers or preserving nature. Okay, but now we just introduced to you our business-to-business model. Let's scale it up. We could offer you a business to government or scale it down, business to customer. So even we would be accessible even to you to solve your everyday problems. And as I mentioned before, the implementation of our system could go even into other sensors or detectors, maybe the robots or smart plugs, and much more. So to sum it all up, we have a modular solution tailored just for you, for your specific needs, that is scalable, affordable, user-friendly. We have data cross-references and integration into an existing infrastructures. So we'd like to thank you all for your attention. And if you have any more questions, or if you'd like to follow us on Instagram, please do so. That is all. Thank you. Thank you very much.
Thank you.
Excellent, very well done. So we can take questions, of course, first of all, people from Asahi, but the floor is open to everyone who has questions. So I'm just going to pass the microphone around.
Thank you.
Thank you. Thank you very much for the presentation. It was absolutely awesome. The solution looks very well, very cheap, I can say. So it's very important for us. Thank you for it. And it was very fast. And all the time in English is fast for me. So I have just maybe some basic questions. And the first is it possible to detect even lower differences between noises? It was kind of calm environment, and then there was very high level noises like the, I don't know actually, what was it, the clap or something like that, or the tool, I don't know the English word for it. So there is a big difference between the noises. So is it possible to detect in a bigger noise or higher like noise level, like lower noise levels?
Thank you for the question. Yes, we are able to do that. We have adaptive threshold for comparing the sounds. So this really adapts to the current environment. Doesn't work like only like that, and maybe we should show that in the demo as well. That's unfortunate, but that's your question.
I have a second question. It's maybe a little bit strange, but I was thinking even during the last week when we were talking together, and I was thinking if you are going to be successful with this project and you have a very good probe, or how to call it. Is it possible to use it, for example, for people who doesn't hear anything? It's not possible to put something what will help them to hear, but to use it just in a form of I don't know, some pop-ups in their watches if there is some dangerous noise like car is coming or something like that. What do you think about this?
Thank you for your question. Myself, I'm in biomedical technologies, and this is a great question, truly. But we didn't look into that during our preparation. We had only 2 weeks, and we wouldn't be able to answer your question just right now, but we could maybe look into it in the future. Thank you.
Thank you. Anyway, I really like it. Thank you.
Thank you very much.
Any other questions from?
Hi there. So my name is Kwang. I wasn't here at the first initial presentation, but really looking back at last year and looking now at the result, it's really impressive. My question would be more related to the device itself and how many actually would be necessary to track what is actually going on in the brewery. So you've been there. You've seen how it looks like. Have you estimated how many would be needed to be able to see what's going on?
Okay, hi, thank you for the question. We thought that approximately just one for each machinery that is doing some specific noise would be needed. Then if there are more bigger machineries that are not producing that much noise, and then the bad noise is louder than others, then maybe 1 per 4 of these machineries will be enough. But of course, the exact number for each company would be decided by its size. So, but if it gives you an example of the number of sensors, then.
So maybe one additional question.
So it's mainly about the problematic places that the problems occur, the effects occur in the most. That's where what we would focus on. But this would require more time to estimate and more time at the brewery, of course.
So maybe last additional very quick question. If you wanted to start a test and learn in the brewery in Popovice, how many devices would you want to deploy so that you would have a relevant result? The minimum, let's say.
Well, we could start always at one per problematic machine to test it out, and if that works, by time we would implement more and more to cover up the whole brewery. So I'm sorry to tell you that we didn't think about it that specifically yet, but for sure there would have to be sorted out a plan for your brewery's specific needs.
Yeah, perfect.
Thank you.
Thank you.
We can take one more question from the audience. Other jury members, people in the audience. I see some hand waving going on, but it's probably something different. Oh, over here, yes.
Yeah, so thank you for a very nice presentation. I would like to ask if you have any like numbers that are coming from the recordings you really collected in the brewery in terms of some like precision recall, false alarms and that stuff. So if you can provide some real numbers.
We didn't record that much data. I think that would be statistically relevant to do some proofs on it. But we use those data to get the patterns in the sounds. For example, when we saw the data coming from the pumps, we saw that they have some predominant frequencies, and the frequency kind of normally distributed around that predominant one by noise. So that's why we decided for the mixed Gaussian models, for example. So this is what we use the data for. I don't think, or probably it would be possible to get that much data, but we were quite busy, to be honest, with the stuff we did already. So we don't have literally like statistical evident data. Sorry.
Okay, thank you.
All right, people, let's give a big round of applause for SenseWise.